You for sure have at least one of these in your home, a smoke detector. We're going to be learning about the mechanism they use to alert you about fires before it's too late. The premise is simple. When smoke enters the detector, make a loud noise to alert the home's residents. Smoke from fires can contain many different chemicals, but they always contain carbon monoxide, carbon dioxide, and suspended solids like soot. This chemical composition is very different from that of air, which mostly consists of molecular nitrogen and molecular oxygen. This difference allows smoke detectors to detect smoke. There are two types of smoke detectors, photoelectric and ionization. I'll only be covering ionization because these make use of a lot more interesting chemistry. Ionization detectors contain a tiny amount of americium oxide. The americium atom is americium-241, meaning its number of protons plus number of neutrons is 241. Americium-241 is radioactive, meaning that its nucleus is unstable and will go through radioactive decay, which means that it will change to become more stable. Specifically, americium-241 undergoes a type of radioactive decay called alpha decay, which forms an isotope of a new element, neptunium-237, gamma radiation, which is just high-energy light, and an alpha particle, which consists of 2 protons and 2 neutrons. The alpha particles are released into the detector's ionization chamber, where they can ionize the oxygen and nitrogen molecules in the air, turning these gas molecules into charged ions. Here's an example of such an ionization. The alpha particle collides with the oxygen molecule and knocks out an electron, resulting in a positively charged O2 plus ion and a negatively charged free electron. Now, there's a positive electrode and a negative electrode in the ionization chamber that are powered by the battery. You can think of these electrodes as simply charged plates. The positively charged ions, like the O2 plus ion, are attracted to the negative electrode. The negatively charged ions and the negatively charged free electrons are attracted to the positive electrode. Since the alpha particles are continuously ionizing air molecules, creating more ions and more free electrons, this creates a small but steady electric current composed of ions and free electrons between the two electrodes. When smoke enters the ionization chamber, the smoke particles can attach to the charged ions, which can either result in a heavier and therefore slower charged molecule, or even a neutral molecule, so a molecule without any charge, which wouldn't be attracted to either electrode. Either way, this slows down the flow of ions into the two electrodes. Therefore, this decreases the current, which, remember, is just the flow of ions and electrons into the two electrodes. If the decrease in current is large enough, the detector will realize this and sound the alarm. And that's basically how an ionization smoke detector works. But I have simplified many of the interactions between the particles. And there are some interactions that I have not mentioned. For example, another molecular interaction that can slow down current is that the alpha particles could collide with the smoke particles instead of the nitrogen and oxygen molecules. The collision between the smoke particles and the alpha particles will not result in ionization, unlike that between the alpha particles and the nitrogen and oxygen molecules. Note that there are other more complicated interactions between the ions and the smoke particles that will also slow down the current. After learning this, you, like many others, might be concerned about the radioactivity of americium. I want to tell you that it is nothing to worry about. Although the americium source is emitting 37,000 alpha particles a second on average, the alpha particles have very low penetrating power. Few even make it out of the detector, and they cannot penetrate the human skin. For the gamma radiation, it is in such low quantities that you will receive at least twice the amount of gamma radiation from eating a banana than from a household smoke detector over the course of an entire year. Another fun fact is that americium-241 has a half-life of 432 years, meaning that for any sample of americium-241, you can expect half of it to have gone through this nuclear reaction and to have decayed every 432 years. Thus, the americium will last a detector for a very long time. The americium and the radiation are rarely the reason for a defective detector. A much more probable problem is a used up or a faulty battery that will not power the electrodes that are essential for operation. So it is important to regularly ensure that you have working batteries in your smoke detectors. Hopefully, you can now appreciate the chemical ingenuity that went into these smoke detectors to keep us all safe. Thank you for watching.